Okay, this is a number 7. What is the ionization energy for an hydrogen atom? And ionization occurs from the state n equal 1 to n equal infinity. So this is an energy needed to excite the electron from n is 1 to n is infinity. There is an equation given in the handout from the textbook. It says 1 over lambda, which is 1 over the wavelength of the light to excite this electron from one state to the other in hydrogen, is RH times 1 over n1 square minus 1 over n2 square. In this case, we are going to say n1 is 1, n2 is infinity, so this will be n square minus infinity square, which will be 0. So therefore, the wavelength of the light inverse quantity will be same as RH, and in RH in the textbook it says 1.1 times 10 to the 7 inverse meter. So that's the wavelength, inverse of wavelength is given, but I need to convert that into energy. And how should I do that? So the energy of a photon that is related to the wavelength of the light, I always start from H equal H nu. Nu is a frequency of the light, which is H, speed of the light c divided by wavelength of the light. So therefore, the answer for this is H times c times 1 over lambda, which is ended up being HCRH. So then we just have to plug in the numbers, and now I just wanted to highlight the units, because this is also another point of this. This one has a unit of 1 over meter. The speed of light has a unit of, if we use meter per second, and then the Planck constant has a joule times second. And if you see that if you multiply those three quantities together as a whole, you'll have a new unit called joule, which is an energy unit. So this one makes sense. So now just plug in the number in that unit shown in above. So let's go back to choose the number. And so 6.63, and this one is 10 to the minus 34. Speed of light 3.0, 10 to the 8, and RH, which is a 1.1, 10 to the 7. And like I mentioned before, instead of plugging all these numbers, you just want to group them together. That will minimize the chances for you to make errors, and then do the power in one location. So plus 8 plus 7. And this will lead me to have 21.9 times 10 to the minus 19. So that will give me 2.19 10 to the minus 18 joule. That's the answer. So where is the answer? 2.19, 2.8, 10 to the minus 8 joule. And the ionization energy, this amount of energy is required to get there. So answer is C. Number 8. Which valence orbital diagram represents the ground state of zinc? So this is a periodic table, how you're going to read this. So zinc is, if you're looking around, there is a zinc, right? So zinc is in the 1, 2, 3, 4. They are in the fourth row, and the closest one next to it is an argon. So argon is the closest one, and then the after argon, you are going to have, this is 4s2, and then let me use a different color. And this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, those represent 3d electrons, which can take up to 10, and the zinc happens to be the one at the end. So therefore, the zinc has the same number of argon, and then 4s2, 3d10. And so which one do they have here now? So answer for this is 4s2 and 3d10. So that's how you can write in terms of, you have 1 up and down, you have 5d orbital, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how you do. And so answer is for this is an A. Okay, so problem number 9 in the exam 1 in Chem 110 in RPI chemistry. So this is a question about quantum number configuration, and now they're asking the 4F. So when people write 4F, 4 means N is 4, and F is trying to represent the angular quantum numbers, which is called L, and there is a notation as P, D, F for L is 0, 1, 2, 3. So therefore, in this case, L is 3 here. So 4F means N has to be 4, and L has to be 3, and then the M sub L, which can range from -3, -2, -1, 0, 1, 2, 3, which is there are 7 degenerate orbitals. Okay. And then the spin can go pointing up or down. So those are the possible ones. For as far as the 4F, this one designates the energy state, and for this 4F, there are 7 degenerate orbital whose energy state is the same. In other words, F orbital have 1, 2, 3, 4, 5, 6, 7 degenerate orbital, and each orbital can take up 1 electrons and other electrons. So they can be overall, the 7 orbital can take up to 14 electrons. So for this one, the N has to be 4, L has to be 3, so therefore D is the answer.